So now we're back to learning GDScript from zero. And this is an open source project by GDQuest.com. All right, so we'll continue where we left off over here at introduction to member variables. All right. So in this lesson, we're going to take a look at variables, a first look at variables, all right? In games, we need to keep track of many values that change over time. The player's score, every character's or enemy's health, the last checkpoint, and so much more. So much more. I mean, it could possibly be endless. If you could work on a game forever and never get it, and it'll never be done. And so much more. We need to store, retrieve, and update those values. We call those values variables. Variables are labels we use to keep track of values that vary over time, right? Here's an example of a variable tracking a character or monster's health. So we got a var health equals 100, right? In the line above, the line above defines a new variable named health and assigns it a starting value of 100. That's what the equal sign does. More on that below. True. So yeah, if you've never seen this, this is an assignment. We call this the assignment variable. It assigns whatever this is to whatever this is. So later on in the thing, we can say health minus 50 when there's a hit, right? Anyways, it's so, I don't know why there's always so many words with it when they describe this thing. Anyway, let's go. So function parameters, which we saw in the previous lesson, are another example of variables. True. In this lesson, we start using variables built into Godot. They're a particular kind called member variables. So yeah, the built-in variables for Godot are called member variables. All right. So member variables are values attached to a game entity. They're useful properties like the position, rotation, and scale of a character. So these are all built into it, right? In a previous lesson, we saw how we could use the rotate function to rotate the character. So we do rotate 0 times 0.3 degrees. And remember, we have that turn left and that turn right. And so the turn left and turn right, if you think about it, those two functions, the turn right had to be using the this rotate built-in thing. This built-in rotate times 180 or whatever it is. We saw the little geometry earlier. They're using that formula inside of that function to do the rotation in degrees. Remember? Anyway, whatever. Let's keep going. So here we got function run and then rotate 0.3 and boom, just like it was last time we saw it. All right. So let's do this. The function increases or decreases the value of the entity's rotation member variable. True. Say we want to reset the rotation to 0 and make the character upright. Using the rotate function can prove difficult, especially if we don't know the character's exact current angle to cancel it out. True. So like if this was at like angle 45.45, right? And we didn't know that. We just said 45. We could try forever trying to get it back to standing straight. Like one eye closed, put a ruler on the screen and put two perpendicular rulers, a protractor. We could try everything we could think of, and it still might even not work. But it's much easier to use a member variable, the member variable, rather than the function. True. So the following code assigns the value 0 to the character's rotation, resetting its angle and making it upright. So yeah, we don't have to reset it with the exact rotation. We just say the exact rotation we need. We just say rotation now equals 0. Once again, run it, boom, upright, just like it was the first time, right? So notice how we use the equal sign to change the value of a variable. Yes, like I said, it's the assignment operator. You know, if you think about it like that, it's the assignment operator. We're assigning 0 to rotation, or we're saying we're assigning rotation to 0. I don't know which way it is. It doesn't really matter because as long as the code works, right? What's a variable? A function that varies over time? I don't know about that. A label we use to keep track of a value that can change? I think so. It has the word vary in it, and that sounds like changing. And then we also got a decimal number, of course not submitted. All right. So variables are labels we use to access values that change over time. We can also use them to put a name on a value we want to reuse. Throughout our code, it makes our code easier to read and to change. What did I say? Let me say that one more time. We can also use them to put a name on a value we want to reuse throughout our code, okay? It makes our code easier to read and to change. There we go. Accessing subvariables with the period, okay? So accessing subvariables with the dot. In video games, we'll see many member variables that have subvalues. For example, the position we mentioned has two coordinates, x and y. It's the same for the scale. It has an x and y subvariable. It has x and y subvariables, right? They respectively control the horizontal and vertical size of the game entity. To access those x and y subcomponents, we add a dot after the variable name, right? So like position.x, position.y, right? The code below places the entity at 200 pixels on the x-axis and 250 pixels on the y-axis. So yeah, position.x equals 250, position.y equals 200, and then position.y equals 250. Run it, and this thing moves over and down like, it looks like it moved over to the right more than it moved down though. Whatever. Anyway, is it not at 0, 0? Is that what the deal is? I bet that's what it is. I bet this isn't actually at 0, 0 right now when we run it. Like it looks like it went down not as much. No, that doesn't make sense. But it doesn't matter. Let's go. Notice how we use the equal sign to assign the numbers on the right to the subvariables on the left. True. All right. Unlike in maths, in computer programming, the equal sign does not mean is equal to. Okay. It means assignment operator. Instead, it means assign the result of the expression on the right to the variable on the left. True. True. A little wordy, but true. We assign values so often in code that we prefer to reserve the equal sign for that. All right. In games, the y-axis is positive going down. We've already gone through this, but we'll go over it again. Note that in games, assuming our character's position starts at 0, 0, the code above moves the entity 200 pixels to the right and 250 down. In math, the y-axis is generally positive going up by convention. True. The convention is the opposite in video games and many computer applications. The y-axis is positive going down. So why does the y-axis point downwards? Let's see. So this may be confusing if we only saw the y-axis pointing up in math classes. True. However, in math, axes go in any direction. Also true. They don't even have to be perpendicular. Okay. On the computer, the position 0, 0 happens to correspond to the top left of our computer screen. It then makes sense for coordinates to be positive when going towards the bottom right corner. Okay, so 0, 0 is right here. So yeah, that would make sense. This leads to another question. Why is positive 0 the top left of the screen? This is due to computer and TV display history. They would calculate and display pixels starting from the top left corner and moving towards the bottom right corner. I guess it's because it's like reading. Yeah, I would imagine it's because it's like reading. That's so stupid. Whatever, right? Whatever. That's so stupid. It's already in the. Wouldn't have to change your perspective if you just did it like math. I don't care. Whatever. We can't change it now. It's way too late. Let's look at one last example before moving on to the practice. The following code makes the character 1.5 times its starting size. Yes, scale.x equals 1.5, scale.y equals 1.5. True. Run it. There it is. Woo! All right, so now we know how to do that also. How do we access subvariables? Variables often hold subvalues, like the position has two subvariables x and y. How would we access the x, for example? Just like this. We would write a dot between the variable and the subvariable name. True. We would write a slash between it. No, that's for accessing folders. We would write an arrow. No, that's for nothing. Submit it. How about we choose something and then submit it? All right, there it is. Oh, I'm sorry for hurting your eyes with that red, wrong, whatever. In a future lesson, we're going to they're going to explain why and how those variables have subvariables. Okay. For now, okay, okay, whatever. For now, we're just going to know that we can use the dot to access them. Isn't it? Obviously, because there's an X and a Y thing inside of this scale. Kind of like there's like, anyway. Oh, are these classes? Anyway, we'll figure that out later. Something about classes and properties of classes. No doubt, object-oriented programming. No doubt, they'll tell us all that later. In the next lessons, we'll create our own variables and do operations on them to add or remove score, health, whatever. For now, we're going to practice accessing variables. All right. So we got the practices right here. We're going to draw a rectangle at a precise location. We're going to use the position member variable and its subvariables to change the rectangle's position. Start right there. Here's the goal. We're going to draw a rectangle of 200 by 120 pixels at the X position of 120 pixels and the Y position of 100 pixels. We need to replace the numbers in the code editor to draw the correct rectangle. Okay. So first things first, we got position, X and Y, and then we've got the draw rectangle function, which we're going to need the length and the width. All right. So we'll start off with the positions. We've got X is at 120 and then Y is at 100. So we'll say 1, 2 right here, and then we'll do 1, 0 right here. So now we're going to do draw rectangle. The rectangle is going to be 200 by 120. So let's do 2, 0 right here, and then we'll do 1, 2 right here. And that should take care of business. Let's see. 1, 2, 3, 4. Looks good. And there we go. Let's go to the next one. All right. So now we're going to draw squares at different positions. We're going to draw 3 squares of size 100 and 100, of a size 100 by 100 that are 100 pixels apart on the horizontal axis. Okay. In other words, there should be a 100 pixel gap between 2 squares. True. We should draw the squares starting at the position 100, 100. This means we should position the first square at 100 on the x-axis and 100 on the y-axis. Remember, we need to use the equal sign to change the values of a variable, like the turtle's position. We're going to write the code inside the run function so the computer can recognize it. And we're going to use the provided draw rectangle function to draw each square. True. True. All right. So let's do that. So let's do the first one. We'll say draw rectangle. No. We got to give it a position first. We'll say position X. Position X dot X equals 100. Come on now. There we go. Position dot Y equals. Come on now. Equals 100. All right, cool. So now we've got that. And now we're going to do the draw rectangle. And we're going to do that 100 by 100. 100 by 100. All right, cool. So now we've got this. We can take it from 4 to the end of 1. Copy that. At the end of 4, we'll drop it off 2 times. We're just doing 2 rectangles. And we're going to change the Y position, no, the X position. So it's going to be 100 on the first one. We'll say 300 on the second one. And the third one we'll do 500. And we don't even need these Ys. So let's just get rid of those 2. Because it's always going to be the same Y. Let's see if this works. 1 square, 2 square. It just zaps right on over there, huh? Didn't do the jump at all. Oh. Oh, whatever. Continue. I bet it's because I didn't change the Y. Whatever. So that's that, and continue. All right. So now we're on to defining our own variables, and we'll see you next time.